I'm back again. We are on day 4 of the types of reactions. We return back to our notes. You will notice that the 4th type of reaction is a double replacement reaction. So yesterday we talked about single replacement reactions where you have a single element that boots another element out of its compound. When you look at a single replacement reaction, you're always left with one element being alone as a product and one element being alone as a reactant. For double replacement reactions, this is different. So in a double replacement reaction, both elements make new compounds. So you have a compound plus a compound produces another compound and another compound. If you look at the general formula, you'll see it says AB plus CD is AD plus CB. So in this case, what you're really doing is you're switching both partners here, right? So if you look at the magnesium example, magnesium gets rid of its oxygen, calcium gets rid of its sulfur, and then they actually switch with each other. So then magnesium has sulfur and calcium has oxygen. Right? It's very similar to like you and your partner, or friend having two different toys, and then, you want the one toy and they want the other toy, so you just switch toys, right? Now you've each got a different toy, but you both still actually have a toy. Right? Same kind of idea. So the worksheet for this is actually pretty simple. If you go to your Thursday work and you look at the double replacement worksheet, I'm going to pull it up right now. You're going to notice at the top there is an example to describe what's happening. So you see Fred Flintstone, you see his lovely wife Wilma, I believe, is that right? And then Barney Rebel and Betty, and I don't know if these are actually right, I just might be making this up, but great, right? So these guys end up switching wives, right? It's very similar to what would happen in a double replacement reaction. So you're going to describe that in that space below. The next part of the worksheet is really just identifying if a reaction is a single replacement versus double. It does say circle the element if it's single. This is really helpful when you're looking at these types of reactions. So for example, if you look at that first reaction here, all right, you're going to notice that you have a compound, another compound, and then when they switch, you still end up with two compounds, right? So you're going to notice that like that Cl and the NO3 here actually switched places, okay? Because you have two new compounds being formed, you would consider this a double replacement reaction. And again, please don't make fun of my horrible handwriting trying to use a mouse to write on here. If you look at number 2, you're going to notice that you have H2O and Fe, and notice that Fe is single, okay? Produces FeO, which is Fe2O3, which is iron 3 oxide, and H2. And even though there's a 2 there, this is still a single element. It's still just hydrogen. So because you have a single element here and a single element here, this is actually a single replacement reaction. All right. So again, in a double replacement, you're going to have two new compounds formed from two compounds here. With a single, you're going to have a single element here in your reactant side and a single element on the product side as well. So for the rest of this worksheet, please spend time identifying single versus double replacement. Okay. And then here at the very bottom, what I'd like you to do is predict the products. Now again, I'm not going to go too crazy with this because it's a little bit challenging as far as making sure that you actually do the crisscrossing and things like that, which we haven't done in quite a long time. However, the idea is that if you take just that back element right here and switch places, right? So in this case, like your Cl and your Br are going to switch places. It's a double replacement reaction. When you do this, you should actually get NaBr plus KCl. Okay, and that's all I would like you to do for that. I will post an answer key for this worksheet. However, I would like you to complete it and turn it in before I do so. All right, well, I hope you guys have a wonderful rest of the day, and I hope I gave you some good information on double replacement reactions.